this video, we're going to be discussing number 15 from the 2020 AMC 10A. So we're increasing in difficulty a little bit here. So let's take a look at the question. A positive integer divisor of 12 factorial is chosen at random. The probability that the divisor chosen is a perfect square can be expressed as m over n, where m and n are relatively prime positive integers. What is the sum m plus n equal to? Okay, so the hardest part of this question is actually just figuring out what all the divisors of 12 factorial are. And so how are we going to do this? Well, there's no real easy way to do this, so let's do this over here so that we have room later to finish the question. So we have 12 factorial, and this is 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. And the 1 is pretty inconsequential, so we don't have to put it here because it doesn't make a difference. But just technically speaking, guys, there is a 1 at the end of there. Okay, and so what I'm going to do in this next step is I'm going to write this equal sign, and I'm going to prime factorize each of these as I go. So 12 is going to be 2 squared times 3. 11 will remain the same. 10 will become 2 times 5. 9 will become 3 squared. 8 will become 2 cubed. 7 will stay the same. Let's rewrite that 7. 7 will stay the same. 6 will become 2 times 3. 5 will remain. We will get 2 squared for 4, and then 3 and 2. All right, so now let's go through and count as we go. So let's see, we have 2 to the power of, so let's underline them so we know we've already used them. So 2, the exponent will be 3. 3 plus 3 is 6, 7, 9, 10. So we've got a total of 10 2's. Okay, let's see what else. We have a total of 1, 3, 4, 5. 5 3's. Awesome. 3 to the 5th power. Okay, let's see. Let's write that 5 a little better. The next factor that we're going to look at is 5, because it's the next largest prime factor. So we have 1, and we have 2. 2 5's, 5 squared. Awesome. Now we're going to take a look at 7, and we have 1 7. And then the next one and the final one is going to be 11. So this is our prime factorization of 12 factorial. So now, we want to know the probability that a divisor or a factor chosen is a perfect square. Okay, so we're going to have to locate all the perfect squares in here, and then the denominator is going to be the total number of factors. So let's go ahead and find the total number of factors first, because that is a little bit easier. It's pretty simple. Total number of factors. And so we have 2 to the 10th times 3 to the 5th times 5 squared times 7 times 11. And so just a quick recap and some review. If there is no number up here, we assume that there is an invisible 1 here as an exponent, since we do have it. Since if it was a 0, we would have actually the value 1. So there's an invisible 1 as an exponent above the 7 and the 11 here. So to find the total number of factors, we will add 1 to each of these exponents. So we're going to get 11. We're going to get 5 plus 1 gives us 6. 2 plus 1 gives us 3. And we have 2 and 2 here. And we're going to multiply all of these together. And this will be the total number of factors in 12 factorial. So we're going to leave it like this for now. 11 times 6 times 3 times 2 times 2. Okay. So now, let's go back and let's rewrite this up here. So we have 12 factorial is equal to 2 to the 10th, 3 to the 5th, 5 squared, 7, and 11. Okay. So for 2, we're going to take an example of these. So there's no possibility for squares with 7 and 11 because, again, we only have one of each. So in anything where we have a power greater than 2, we can use these three factors, 2, 3, and 5, for our perfect squares. So we have 2 times 3 times 5, and we can have any combination of these. And the numbers that we can use are the even numbers beginning with 0 and ending with the highest even number before the power that we have here. So in this case, for 2, we have 0, 2, 4, 6, 8, and 10, giving us 6 possibilities. Okay, 1, 2, 3, 4, 5, 6. For our 3, the exponent, so I'm going to put a little space here so we know what we're doing. The exponent that we can have for 3, we can have again 0, 2, and 4, because 5 is the highest, so we can't go above 4 to get 6. Now finally for 5, we get 5 to the 0 power, and we get 5 squared, because 5 squared is the highest power of 5 that we have. All right, so we have here, from this one, we have 6 ways. From the middle one here, we have 3 ways. And from this last one, we have 2 ways, for a total of 6 times 3 times 2. Now, we want the probability, so the probability that we're looking for is equal to 6 times 3 times 2, so the number of ways, the number of squares that we have, perfect squares, divided by the total number of factors that we have, which we found over here. And so now we see why I left it in this form, because it's very similar to what we have on top. So we have 11 times 6 times 3 times 2 times 2. And so we're just going to cancel what's the same in the top and bottom. So we can cancel 6, 3, and 2 with 6, 3, and 2. And we're left with the probability that we are seeking as 1 over 23. Or 1 over 22. Sorry guys, got a little ahead of myself. So we have 1 over 22 is this probability that we are looking for. Now, we are told that m over n needs to be relatively, m and n need to be relatively prime to one another, and since one of them is 1, we have already accomplished this, so this is fine. So m plus n then will give us 1 plus 22, or 23. Okay, so the key to this question, guys, was just being able to brute force this prime factorization of 12 factorial. And that'll take some time, but once you've gotten it and you understand how to make these perfect squares, as well as how to find the total number of factors for 12 factorial, this question becomes relatively simple and easy to work with as long as you know its component parts. Alright guys, so this was number 15 from the 2020 AMC 10A test. As always, drop a like and please leave a comment with any other solution that you may have had. You can also leave me a comment requesting a specific question from any of the AMC 8, 10, 12 tests or math counts competitions.